Welcome to the Epik Mellon podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe. In this episode, we talk to Bjorn Iver Teigan of Domos about why latency matters and a view of our industry when coming straight from academia. All right. Hi, everyone. Welcome to episode 3 of the Epik Mellon podcast. I'm your host, Jason Walls from QA Cafe, and I am joined today by Bjorn Iver Teigan. And he and I are actually pretty good friends from the work that we do together. And he comes from a different side of things than some of the other people we've talked to so far, and has some very interesting insights into the realities of the networks that we deal with. So we're going to talk about a lot of that today. But first, the usual, this podcast is obviously entirely funded by my employers, QA Cafe, and we have a couple of major products that we build for the network device testing and network analysis industries. The first is CD Router. CD Router is the industry standard test solution for broadband gateways, Wi-Fi routers, and other customer premises equipment. CD Router contains thousands of test cases designed by network experts, some of whom in the room out there, covering feature validation, stability, certification, and performance all at once. It is designed with full automation in mind, with a robust API that lets developers work seamlessly with their CI/CD environment. Since its use is so widespread among operators, manufacturers, OEMs, and chipset vendors, the ease of replicating tests and communicating requirements between customers makes it the de facto standard for testing. Moreover, QA Cafe's world-class support team acts an extension of your own, helping you understand the technologies and build better products overall. Our second product is called CloudShark. CloudShark is the way to make network packet captures an easy and useful part of your networking, IT, and cybersecurity workflows. CloudShark takes complex tools like Wireshark, Zeek, and Suricata, and presents them in a truly accessible way to you, your team, and your customers. CloudShark helps you work on tough issues together. Recently had someone describe it as making cybersecurity into a team sport without passing around large trace files, losing data, or risking security leaks of valuable information. In addition, CloudShark is designed to help entry-level analysts learn from your senior experts, curate best practices, and standardize operating procedures around packet captures. And lastly, QA Cafe's Passport is a fully automated solution for testing the connectivity and interoperability of IoT and smart home devices. By emulating a real home network, Passport enables repeatable network testing for ensuring your IoT and smart home products behave as intended for your customers. Designed with ease of use and automation in mind, testing with Passport is as simple as connecting your device, selecting tests, and getting clear pass-fail results with full log data and packet captures to find and resolve bugs before they end up as a bad review of your product. For more information about CD Router, CloudShark, and Passport, visit us at www.qacafe.com. Now, the quick disclaimer I usually give, obviously, even though this is essentially a QA Cafe podcast, my opinions and the opinions of the guests on this show do not reflect those of QA Cafe itself or its ownership. Because I'm sure we end up telling some pretty crazy stories that should probably remain under the rug, but here we are. And I'm sure things go similarly for Bjorn. Bjorn is with a company called Domos, and naturally his opinions are his own and not representative of Domos.
Oh, no. Domos fully stands by all of my opinions. I'm sure.
I believe that, actually. It's like when you go all in. Yeah. What is it? I wanted to bring up. I brought this up a few times. So this is episode 3, which is really great. I'm glad to have Bjorn here for this. And I had sort of explained the title of the show in the last 2 episodes, which without going into me mispronouncing it once again, Epik Mellon is a portmanteau of the Greek for the future of communications, or Mellon epikonoion, right? But as Bjorn wonderfully pointed out, Mellon is also the Elvish word for friend.
Yeah, it's how you enter Moria. It's how you enter the mines.
All right. So yeah, we're here to talk about the crazy world that is networking, not just the technological side, but the human side as well, and get a little bit of information about how the sausage is made. As I was talking to Tim Winters in the first one, we're kind of talking about how the internet doesn't work by design. It's almost kind of by accident, right?
It certainly feels that way
big
sometimes.
hodgepodge, right?
Oh, yeah.
And but it works, and it's like, do you want to tell people that, it has our back? But it's that self-organization that I think actually provides some of the stability, ironically, right?
Yeah.
Yeah.
It is pretty cool.
So talk a little bit about how you got here, right? So we know, you could talk a little bit about Domos, but also sort of how it is that you're even in the position that you're in to begin with, and how you got interested in all this stuff.
Yeah. Cool. So, hey, everyone. My name is Bjorn Iver Teigan, and I'm head of research at Domos. And maybe first, a quick introduction of what Domos is doing. So we're a latency management company. So we measure latency from the home routers of ISP's customers. So we sell software to ISPs, and then we sit in the home router and measure the performance of the home networks. So we measure delays, and then we investigate if interactive applications like video streaming or like video conferencing and that kind of stuff is working as well as it could be. And if it's not, then we can flag that, report it to the ISP, find out what the problems are and that kind of stuff. And I mean, we're a startup, and we've changed our focus several times, but it's pretty much sort of the same problem space as it was when I started. So I actually got into networking sort of by accident, really. I was studying.
It's funny you say this. So that's like the subject of the show, right? Is how all of us got there. None of us did this on purpose.
You mean nobody gets into networking on purpose? Is that
no?
Well, I was studying computer science though, so that was I was sort of, it's still in the ballpark. But I was studying robotics and artificial intelligence, and then one of my colleagues, Magnus, who was sort of in the class 1 year before me in the university, started working at Domos, and I asked him if they needed any like summer interns, because I was looking for a summer job, and they did. So I showed up at the office and did some stuff for a summer, and then it turned into this part-time 1 day a week while I was doing my master's thesis, and then I've been working at Domos ever since. So yeah.
And hi, Magnus, if you're listening.
Yeah, he said to say hi. He did.
Good. Yeah. So that's interesting. So you're the stuff you were working on for your master's, and then most recently your PhD thesis.
Yeah.
So I hear. Talk a little bit about that, because it's from all the conversations that you and I have had about this, it's revealing the ugly side of a couple of things that we don't realize about networking, right?
Yeah. So after I started at Domos, about half a year after that, I applied for this PhD program thing where I was still employed by Domos, but did a PhD as sort of a full-time employee, and then there's all these rules. You have to do something that's useful for the company, and da 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 da. Anyway, I studied latency modeling, and specifically of Wi-Fi, and then how that interacts with how the variability of Wi-Fi, because Wi-Fi is an unreliable network link protocol.
Is it?
And yes, as you well know, so I also looked into how those variations affect things like TCP, because TCP is the congestion control algorithm on the internet, interacts quite badly, I would say, with any sort of variability that's not sort of the kind of variability that it expects to see and has been sort of designed to deal with, right?
Right.
And that's
and people don't realize that the reason behind that is because TCP itself is significantly older than Wi-Fi.
Yeah.
Right. And
Yeah,
like
yeah, yeah.
Tim and I were talking about this, how it's like a lot of these technologies, standards in particular, when they get designed, they're designed by people who are solving sort of an immediate problem, right? And then they get sticky, right? Because they're
Yes.
so good at what they did, right? They
Yeah.
get sticky, and that's how the internet works. Is there's a bunch of technologies that have sort of like glommed onto each other, right?
Yeah.
Because they were just so dang useful, and then people wrote them into into devices and software knowledge, right? So like people have been trained on this stuff for 40 years, right? And they don't want to learn anything new, or it's not efficient for them to learn anything new. So we have this situation. We have older technologies that are trying to operate into new situations, and then we
and then you get all kinds of performance problems. And another thing is that, I mean, the internet was designed to enable sharing of resources and being able to log into a computer from a distance and all that kind of stuff, right?
Right.
And then it's evolved into this thing that we rely on to have like everyday conversations and make
literally everything.
Yeah, literally everything, and things that can't wait, right?
Right.
With the way the internet was designed, it was not designed to be able to do real time stuff, really, right? So
Right.
so we run into all these kinds of issues, and they're hard to fix because, as you say, all the solutions and things are built into literally hundreds of millions, if not billions, of physical boxes running software that's not easy to update, and sometimes it's like even in the hardware, right? So changing things is really a problem. Yeah.
So how did let's go down that road. So like TCP is not good at dealing with that situation. So what is it that you ended up sort of studying about that?
Yeah. So so Wi-Fi is like the quality of a Wi-Fi link will vary based on like many different things. Like even just if you move around, it changes. If your neighbor,
if you're having a bad day,
it's like the weather will change your Wi-Fi link. So it's crazy. And TCP is specifically designed, or it's really designed to work well, or to utilize links to their fullest. It wants to basically use all the resources that are available, which is fine when the amount of resources available is a constant size over time. Like TCP can try different levels of throughput end to end, and then figure out what the ceiling is. Like if I go faster than this, it stops working well, so I go a little bit slower, and then it sort of bounces around this target threshold that is the capacity of the link. But if the capacity of the link is changing all the time as well, it doesn't work as well. It's like if you're driving on the highway and you're going the speed limit or faster than the speed limit because it's the highway. You can go 100 miles per hour, no problem.
Nobody goes the speed limit unless you're in Ireland. Where
exactly.
That's not the speed limit. This is like the maximum speed you can safely go on this winding road without killing
totally,
yourself.
Yeah. And but then imagine if like suddenly parts of the highway is like no longer a highway, it's like a dirt road, so you hit that dirt road at 100 miles per hour. That's what TCP does with Wi-Fi, because sometimes Wi-Fi is a highway and then sometimes it's a dirt road, and it changes like in the snap of your fingers. So that's a problem with TCP, and it's a problem with any end-to-end congestion controller. So it's like any changes that we make to TCP, like there are a bunch of really good improvements that you can make to congestion controllers to make their performance work even better in the cases that they are designed to handle. But this case with Wi-Fi changing capacity all the time, it's something that congestion controllers can't even in theory handle, because the changes are on a time scale that is sort of shorter than the round trip time and the sort of the time scale at which TCP tries to optimize things.
Right. By the time the feedback information has gotten back,
yeah, it's way too late, right? Yeah.
Yeah.
It's like if you're hitting that dirt road, it doesn't help to be told like 30 seconds after that the road is going to change. You're already
right.
You're already gone off the rails. And
hey, did you know you're on a dirt road now?
Yeah.
Oh, am I? Thanks.
Exactly. Yeah. So that's an interesting problem, and it's it makes it so that, I mean, the thing that we obviously have to do is to change all of the places where we need to change the behavior of those links that are unstable, so that we can either make it seem to TCP that they are stable. So you can there are some tricks that you can do to trick TCP into thinking that it's running on a more stable link, or at least sort of let interactive traffic avoid those problems that TCP or congestion controllers are causing. Or, I mean, just rate limit is also an option. You can if you want to go, just go slow on the highway as well. And then if it turns into dirt road, you're fine. That's one option, but that's usually ISPs don't really want that option, because or customers don't want that option, because it's like throughput you want.
Well, let's talk about that for a minute, because that's the weird reality that we're in now, where, you know, you and I have talked about this hundreds of times, where it's like the way that broadband has been advertised to consumers has always been about bandwidth.
Yeah.
Right. And that metric is very easy to market, because you can be like, oh, you know, 300 is a bigger number than 100, right?
Yeah.
But it turns out that that's not the reality of what's going on at all. And what you were saying before, I remember, is that in some cases, the even not even from the Wi-Fi perspective, but trying to maximize the amount of bandwidth that's going to the consumer ends up making their experience crappier, right?
Yeah, that's an interesting point as well. I mean, the highway analogy is not perfect, but it works in this case as well, kind of, because it's like if you've got a like I do, have a bit of a shitty car. I've got a Hyundai i20 from 2009 that is top speed is probably like 150 kilometers or something like that per hour.
Yep.
What's that in miles? 110, something like that.
Is it?
100. Yeah.
Divide by 2.6 or 1.8. Divide by 1.8.
Right? Yeah. And so if the road can support going the top speed of your car, then building like an even nicer road with even more lanes and even more like smoother asphalt or whatever, it doesn't help you get anywhere faster, right? Because it's like limited by the car. And it's a bit the same thing with bandwidth in networks. Like video streaming 4K is probably like the highest bandwidth use case that you need sort of continuously. And that's like 20 megabits, maybe 25. Right. And most, I mean, probably not true of all places, but like in Norway, 100 megabits per second is like a completely normal internet connection. So if you have 100 megabits per second, you don't need a gigabit, unless you're unless you're very impatient when you're downloading games or something like that, right?
I understand the argument. Well, actually, let's talk about that a little bit, because there's the use cases that a lot of operators are saying is that, okay, well, you have a whole family and everybody's watching 4K video at once or something, right? Or you have one person that's watching a 4K video and another person that needs a super, super low latency application like gaming, right?
Yeah.
And those things are happening at the same time. And I don't want to, I know, you know, I'm going to hear it later where people are like, oh, Jason said you don't need any more bandwidth. Did I ever tell you that story? I was at a rural telecom I won't say the organization. I was at a rural telecom association of some kind, right? And I was
Okay.
speaking on a panel there, right?
Sounds ominous.
And I was sort of invited to talk about testing and stuff like that. And they asked, this was 2007, I think. So this was 15, 16 years ago.
Yep.
And so imagine the available bandwidths back then.
Yep.
And they were like, you have all of these tier 2, tier 3 guys there, and they desperately want to hear that they don't have to upgrade their networks. That's what they want to hear, right?
Yep.
And so they asked us, and it was me and a guy from Google and somebody else, and they asked us, how much are we going to need in the future? And I made the mistake of saying, well, me personally, I do use more than 3, right, at the time. And they like jumped on it. We're like, see what he said. So as much as we're saying that as things stand right now, you don't need more than 100 meg. I want to throw a bone out there to the people who are upgrading their networks to provide 10 gig links and all that stuff. I'm sure that there is a time in the future that will be necessary. But in the meantime, need to pay attention to the actual QoE.
Yeah.
Right?
Yeah. And I mean, more bandwidth is good, probably, right? I mean, you can download things faster if you're a gamer. Downloading a game these days, I mean, they can be tens and hundreds of gigabytes sometimes. So obviously those things are faster if you have a better link. That's not controversial, but I think, and I mean, the 100 megabit. It's as you say, with a family, or maybe in the future we have like a more high fidelity, like streaming VR experiences or something like that. You can imagine like finding a use case for those things. Right. But I think, as you alluded to earlier as well, one of the things that happens when optimizing networks for more bandwidth is that basically you want to aggregate more, because basically you want to make your packets bigger, because all packets come with some kind of header, and especially on wireless, there are preambles and stuff that, because of legacy reasons, have to be sent on like low rates, so they're slow, they take up a lot of time. So basically you want to minimize the time that you spend doing all this coordination overhead stuff, and that means you want to pack as much data as possible into each transmission, and then you have to do that to maximize throughput, because otherwise, I mean, you're limited by the amount of overhead that you're creating. And that is a good way to create more throughput, but it basically means that what the unit that you're sending, like in time, is a big unit. So in Wi-Fi, the transfer opportunities are typically like 2.5 or thereabouts milliseconds, and that doesn't sound that long. But if you're standing in line behind 10 or 20 other transmissions, then suddenly you're waiting, 25, 50 milliseconds for the Wi-Fi link to become idle. And sometimes you're waiting for way more than that as well. Like you can be unlucky and have to wait for 100 of those transmissions or whatever. So it's like that introduces a lot of variability, and having smaller chunks, like if you're waiting behind 100 chunks, you want those chunks to be as small as possible, right? Because if a chunk is half a millisecond, then 100 chunks is just 50 milliseconds, not that bad. But if they're 2.5, it's 250, and then you're starting to have problems with video conferencing and gaming and that kind of thing. So it's it's a trade-off in those cases, because you get more throughput if you make the chunks bigger, but you also get more variability and less reliable real-time stuff. Right.
So so at Domos, like, how are you guys? And I guess I would feel free to fill in a couple of war stories, sort of what you guys have seen so far. But so how is that done? Because I know the coordinating the Wi-Fi situation is one of the biggest things that you guys do, but it's obviously more than that. So can you give sort of an example of how that works when, like, let's say, you are doing streaming and gaming at the same time, and you're trying to optimize these two different applications and stuff like that?
Yeah. So, yeah, the case where you're doing streaming and gaming at the same time is a good example because, so in that case, you'll have two competing flows going through the Wi-Fi access point, and one of them is like a bursty thing that will, like, when streaming video, you typically get like every 5 or 10 or 15 seconds, it will download the next 5 or 10 or 15 seconds of your video.
Right.
So it's like a bursty process that it's idle for whatever time it has left, but then every time it triggers a new update event, you get this whole burst of packets coming through, and that will sometimes cause problems with interactive stuff like gaming or video conferencing, because those packets for the video stream will take up too much resources and cause problems. So the way that we're solving that is basically to use the built-in QoS features of the Wi-Fi standard, which already has these ability to basically sort traffic into, like, this is urgent, this is even more urgent, and this is not as urgent. So you can tag packets. So in this case, we would tag the gaming or video conferencing traffic as more urgent than the video streaming, and that solves the problem without causing any negative side effects, because a video streaming application will it basically just needs to finish downloading the last chunk before it needs to ask for the next one. Otherwise, it'll sort of see like, oh, I have a problem, there's not enough bandwidth, and reduce the resolution or something like that.
Which I'll be totally honest, it drives me nuts, especially on
super annoying, right? But
yeah, well, because what I would rather do, like, and I'll say this, Amazon, if you're listening, right? As a Prime user, this is my user request. I would rather you pause my video and give and do a bigger buffer.
Yep.
So I'll go up and do something, than pixelate my freaking 4K video that I want to watch.
Yeah.
You know?
Yeah. Super annoying. I totally agree. And it's that's one of those weird things, because
and then they say, we're trying to deliver you the best experience. I'm like, this is not the best experience.
Yeah.
I would rather see a spinning circle with, like, maybe a progress bar or something that you tell me when I'm going to be able to watch the movie at the resolution that I want to watch it at.
Yeah. I don't know. I can't remember where I heard this, but I've been told by someone, I'm sure, that one of the reasons they will do that is legal reasons. Like, you're not allowed to download more than a certain part of a movie. Otherwise, it's like piracy.
Geez. Yeah,
because the streaming license limits the amount that you can you buffer at the client, which is stupid. But
that's so dumb.
Yeah, that might be one of the reasons why
I bet
that kind of thing is happening. Yeah. But
I
totally agree,
write in and tell us if that's true.
Yeah, because if you could download the whole movie, like, just schedule, I want to watch this later. If you have a flaky network,
right,
that would be a great feature, right? Because then you would know that this is
right. And I don't care if you get rid of it later and you lock down my ability to, like, store it. Just, you know.
Yeah, someone should do that. I totally agree. No, but with the streaming and gaming example, it's like as long as, I mean, there are corner cases where you will run into, there is just not enough resources to do both at the same time. But if there are enough resources to do both at the same time, basically prioritizing the interactive traffic over the video streaming traffic does not hurt anyone. It's just fixing a problem without causing any issues to the streaming.
Right.
Because the streaming is just sort of divided up over slightly more time, but it doesn't matter because there's a buffer that will cover for that difference or make up that difference. Whereas that's not possible for something that's interactive, because with a video conference, you can only buffer so much without people sort of starting to talk over each other a lot, or wondering if the other end is still there or listening, or
So that's a great example. So the video conferencing, which is it's so interesting that this particular use case became so important over the course of just a 2-year span. was right.
Oh yeah.
uh, the funny anecdote I always tell is that Zoom, the company, right, had no idea what they were in for.
Oh yeah.
They just happened to be like the best. They just happened to have the best SEO at the time.
Yeah.
Of people looking for video conferencing services. Like, so hats off to their marketing department, but they weren't ready for what was about to happen. Right. So you have, there was all the security issues or whatever, but just, in sheer, the sheer resources of them as a company. And I remember when everything exploded, Zoom, the company who makes broadband gateways, is an entirely separate company from Zoom, the video conferencing company. But when the things went down, the investment world was like, "Oh, we need to buy shares in Zoom," and they bought shares in Zoom, and it was totally the wrong. I mean, I'm sure they got a great deal because Zoom is actually a pretty good company, right? But they had to stop. I heard this. I don't know if this is true. They had to stop trading because everybody was buying the wrong company.
Yeah. Oh, that's funny.
So like overnight, this became the killer use case, right? And it's interesting because it is a combination of those two things. Like it's like you're saying, it's like video streaming on its own. There's stuff going on behind the scenes that make it so it's not exactly real time, right? And then for gaming, it's real time, but the overall bandwidth isn't that necessary because most of those games, unless you're doing the new streaming stuff like Stadia and all those things, unless you're doing that, the amount of data that's being passed back and forth is not very much, and they designed it that way on purpose, right? It's like you are installing a game that's multi dozens of gigabytes on your PC, so you have all the graphics and all the information, right? And then the actual communication protocols are very small.
Yeah.
Now you have video conferencing where it's the union of those two worlds.
Yep.
Right. And that's the situation that you guys are running into, right? So is there anything different about optimizing that situation? And is there anything that you guys are doing to sort of solve that TCP problem where it's better for the data rate to be consistent?
Yeah. So most video conferencing is using some kind of UDP based protocol, but they do, as we talked about with the 4K stream, they do like they adapt the video resolution, so that, which is similar to what TCP is doing, right? Because it's trying to figure out how much data it can reliably transmit.
Right.
And the thing that we're doing there, I mean, it is using all the Wi-Fi QoS features, and then it's monitoring how well that's working, and making sure not to basically overdrive, because you don't want to prioritize too many things at the same time. So it's like,
right.
I mean, and the way we're dealing with that is to let the end user actually choose, like, what do I want to prioritize? Is it video conferencing, or is it gaming, or is it, because, I mean, you could imagine that just like prioritize everything that's interactive, but that might not work all of the time, because as I mentioned earlier, you can run into these basically there isn't enough capacity to serve all the different use cases well, and then you basically have to make some choices, right? It's
right.
It's like if you you have to reliably be able to give enough resources to the applications that you want to ensure that's working well. You have to be able to always have enough resources available. And if you have too many people coming to you and asking for resources, you have to say no sometimes. Otherwise, there's just not enough. So, yeah,
as in life.
Yeah, it's just not that hard, but yeah.
Yeah. What was I going to say about that? Yeah. So is that done? That's done sort of for the user-facing application that the operators are providing to them.
Yeah, we basically we make the tools available, and then ISPs can integrate it into their own solutions. Right? So we don't have a Domos app, but we do all the functionality in the back end.
Cool. And that's becoming easier and more possible now than it was in the past, I assume, right? Because you're having sort of better gateways that are a little bit more modular.
Oh yeah, totally. The whole USP stuff from the Ruban forum with containers and making it easy to basically communicate with a controller in the cloud somewhere that makes all of these things possible on scale, at scale. Basically, it's like
Right.
it wasn't that it wasn't that it wasn't possible to do that before, but you had to basically integrate with all the different vendors and all the different wacky versions of Linux that whatever the
Yeah,
CPU providers might
right.
come up with, right? And the overhead on integration would be too much without the
Right.
standardized solutions and tools. Totally.
Cool. So let's talk a little bit about that, just from the human side perspective. Like this entire set of projects ended up getting you involved in the standards world.
Yeah,
What's your experience so far?
that's a good question. It's standards. It's well, first, my first impression was that it's hard to understand, like to wrap your head around, because everyone's speaking with like a crazy amount of jargon and abbreviations for everything, and reading documents is like you have to spend an hour a page because you have to go look up so many things to
Yeah.
even start to make sense of things. And so it was a bit overwhelming to start with.
Yeah.
But also, I mean, people are very friendly and very welcoming as well. It's like it's a great community with and that's been the case with all of the standards organizations I've been involved with.
Good.
So
I was gonna ask what your experience with the ITF was, because it's said definitely bigger than
than
the stuff
it
that
is
you and
much
I worked
bigger,
on at the Broadband Forum. It's just we're pretty small. I mean, the stuff we're making is pretty cool, but it's still a pretty small group in terms of the number of people in the room.
Yeah.
But with the ITF, I mean, that's what, on the order of 1,500 or something.
Yeah. The ITF it's even more confusing than the Broadband Forum, right? Because there's like,
by a literal order of magnitude.
Exactly. They're 10 times as big, and there are 10 times as many abbreviations at least, right? So so that is a bit sort of daunting as well, but yeah,
and they're not even 3GPP.
Yeah, exactly. Yeah, or ITU. I heard they're not better with the TLAs. So yeah.
But no, you found it was pretty welcoming there too, like sort of like it was easy to get in.
Yeah, I did. I
get a running start.
Yeah, it's this funny culture, because it's like on one side people are very very friendly and open, and it's easy to sort of get in touch with people in the hallways and sort of start conversations and all that kind of stuff. But it's also a culture of sort of ruthless criticism of each other's work and that kind of stuff. So it's but I like that. I mean, it's a good productive way of talking to each other. I mean, with Broadband Forum, it's like 4 events a year. ITF, I think, is 3.
Mm-hmm.
And with like 3 or 4 weeks a year to meet in person and talk about things, it's a good policy to be like direct and get stuff right? Done, right? So
especially so like good. during the pandemic, when we had sort of half as much time to do everything than we normally would, and not the ability to all go out after and sort of decompress and hash everything out. It was very different.
Yeah,
because it's like you're saying, it's like we can have we'll have arguments and fights, but then everybody goes out for a beer after. It's fine.
Yeah, and that's a sort of I mean, from the outside, I don't think it's easy to understand how those things work, because it's like in the actual meetings that you can join with a web stream or that kind of thing, and you can see the minutes afterwards. It seemed like things are like moving very slowly, and it's very, very boring sometimes.
Yeah.
But then the actual work, I think, or at least a lot of the value of these organizations is created with the hallway conversations and going out to the pub and having dinner and getting to know each other and learning from each other and all that kind of stuff.
Right.
So, yeah.
There's so much stuff that I've learned from you guys, like just in the span of time that, you started the projects that have been started at the Broadman Forum. There were things that, it's very cool to have your perspective.
Oh, thanks. Yeah, likewise. I feel like you were one of the welcoming people at the Broadman Forum. Yeah. And also one of the direct ones because, as well.
Well, because right. It's what was it? Tim Winters put it really well. He was like, it's very much like going to a roller skating rink, right? And there's a bunch of people who are all good at skating, and they're skating in the circle. And you sit there and you're like, whoa, how do I even get on the floor there? And you have a couple people who are like, hey, come with us, right? And you're like, okay, don't fall. Okay, now you got it,
Yeah.
But at the same time, it would be like, fix your footing. Why are you wearing?
Yeah, exactly.
No. So it's I try to do that because I've been there, right?
Yeah.
And when I started, I was a 25-year-old, almost grad student, and I walked into I went to go talk about DSL testing, right?
Yeah.
Because I went with a couple other people from UNH, and I was like, well, there's enough people in this room. I'm going to go wander over to this other meeting when they happen to be talking about Tier 69 testing.
Yeah.
Like at the moment that I walked in. And it was, it is, I realize this is kind of cliche, but with standards, and I really, really want to make this point to anybody who's listening, who's considering participating in standards work, because we need your help. Everybody needs your help, right? We need people who are willing to do work.
Yep.
And it could be intimidating at first. And, I encourage people. I know it sounds cliche, but you will get out of it what you put into it. You absolutely will, all the time, right? And that's what happened to me. Whereas I was like sitting there and I'm like, okay, here we go. Let me take off the anxiety backpack and I'm going to say something to these total strangers that I've never met before. And then that's where we are now. That's why I am where I am now.
Yeah, it's a great way to get some actual feedback, right, on the work and some impact as well, because if by making things available to others, they can build on it as well, and then there you go.
Oh, true. And the feedback is a huge point, right? Because even if whether you're coming from academia or you're coming from a company that has like built something and like they've kind of had their nose to the grindstone for a while and they've built this one thing and they know everything about it. And then you come to a standards meeting and you're like, this is what we have. And all of a sudden, like all of these things you didn't consider are suddenly being revealed, right? Yeah. Maybe harshly a little bit sometimes, but
yeah, but really usefully. So I totally agree. And it's, I feel like the format of feedback is, it's a really good way to do it because you're actually in person and you can, if you don't understand what people mean or you feel like they've misunderstood you or something, you can go up and talk to them and ask and have a conversation and work it out, right? So and that's, you mentioned my PhD earlier, and the way that you get feedback in academia is very different, right? At least it was for me because I did the PhD during the COVID years, so it was like so it was like all anonymous reviews, which
that's rough.
Which is, much less useful because sometimes the reviewers don't understand what you mean, or sometimes you don't understand what they mean. Right? Yeah. So either way, in both of those cases, you don't really get the value. So. I feel like and it's also like in academia, it's not always about using each other's work that much, but I feel like in the standards organizations, it's really people want to build on each other's and help like or collaborate to build something together.
How do you mean? Because I would have thought that was sort of the point of some of the academic work, is that people do.
Well,
that.
it is.
Is that not?
It is. It is. I mean, the difference is maybe not that big, but it's. I feel like the collaboration is better with standards, because the point is to agree on this is how we're going to do things, and the value
It's
comes.
Like everybody goes into it knowing.
Yeah, the value comes from everyone doing the same thing, right? That's the point of the standard. Like if everyone keeps doing their own version of the standard, it doesn't work. But in academia, it's sort of almost the incentives are lined up for everyone to go in their own little direction, because if you're too close to someone else, then your work isn't novel, right? So you have to basically branch out
really
a little
what
bit.
The goal is, right?
Yeah. It's one of the criterions to get published, right? Whereas in standards, it's just the criterion is you have to agree with everyone, or you have to get everyone to agree. So yeah, I like that part of it.
Right. Well, no, that's great, because that means that it's, in theory, it's going to work, right?
Yeah, in theory, yeah. And design by committee is not always great, but sometimes it can be good.
Oh, right. And like legacy stuff is probably the biggest problem, right? Because we have decisions that were made, and it's like, well, we can't go back now.
Yep.
Unless we rip open this whole thing. And that's how USP was born. Yeah. We were like, is it time? It's time.
Yeah. Yeah, but that's good though. I mean, that's what you want to do, I think, with a lot of this stuff. Is like you get to a certain point and it's like, it's time for the next generation, and then actually build the new thing. It's yeah.
And I always like to think, the Broadband Forum in particular, but I'm sure other organizations are sort of in addition to being standards from a protocol design and technological perspective, it's also sort of a where the rubber meets the road perspective, right? Because you're getting the real side from the operators who are actually trying to deploy this stuff, and what their time scales are like, and let's talk a little bit about that. How open, like how amenable are operators to solving these problems in the way that you guys have done it, right? Is it kind of an uphill battle to sort of explain the value, or is it sort of a, oh, well, yeah, we haven't had this problem for a while, I'm so glad you showed up? Like,
yeah, that's a good question as well. I feel like it's impossible to answer in sort of the ISPs are like this, because an ISP is a company with like tens of thousands of employees sometimes, right? They're huge, right? And it's always possible to find the person or people or team or group who get it right away, and who has had this problem.
You have an internal champion kind of thing.
And they've been looking for a solution and are very happy to find someone who's working on the same problem, right? And have a solution for them. But then it's also uphill battle is maybe too strong, but it's a long process to convince all of the stakeholders that have to agree and sort of go through the process of integration with all of the systems and teams and all of the stuff that goes into running an ISP. It's a huge undertaking. So the sales cycle is long, and you have to have a lot of patience.
I understand that.
Yeah, and it's always longer than you think. So it's no matter how long you think it is, it's always a little bit longer.
Right. And I know, a lot of us sort of give ISP shit for being like that, or being,
but it's not
the ones that are bigger or slower, kind of dinosaurs. But a lot, there are a lot of T's to cross.
Exactly. So and it's definitely not because, I mean, it's not that ISPs don't want to build better networks.
Right.
They want to build better networks, but they don't. I mean, big companies don't know how to change quickly. It's basically,
right.
and they're basically decide not to do so as well. They want to make sure that any changes that they make are actual improvements and that they're worth it and all that kind of stuff. So it's a lot of testing and validation and
Right.
testing business cases, testing user experiences. I mean, technical validation of all the different things that go into a total solution. So it's that makes changing things hard. But it also makes sure that once you've gone through that whole process, there is no longer any doubt that the actual solution is providing value, right? And it's actually
and having I imagine having a lot of that data helps. Have you had any moments where it's been sort of a wow moment where people are like before, after, and they're like, whoa.
Oh yeah. We do a lot of like actual live demos as part of the sales process because it's so easy to sort of show the actual impact, and then we get a lot of that. So
good. That's I would hope that would be the case.
Yeah.
Cool. All right, dude. Thank you very much. Do you have any other things you want to talk about before we wrap up?
I would like to mention that we're moving into actually helping the application side of networks as well with something that we call network Xray, which is basically it's a plugin or a HTML snippet that you can put in a website or in an application or an app to measure the quality of the network from inside the actual application. And then if you have a Domos software on the home router as well, you get the insight from the router in the application. So if the application is detecting a problem, you can basically ask the router, do you know what the issue is? And sometimes the router will know what the issue is, right? So then you can surface the problem and the solution directly in the application.
That's super important.
So that's something that we've been working on the last couple of months, and that we're very excited about. So
that's really cool because you don't have to ask any humans in that process.
Yeah, I mean,
right?
And it's about making the problem resolution easy and sort of accessible when there is an actual issue, right? Because nobody wants to like go check their network quality all of the time. That's not
right.
It's like if you're already outside, you don't want to check a weather app, right? It's like you know what the weather is. If it's good, it's good. But
I'm guilty of. I'm that guy that will be outside and be like, "Wait, what does dark sky say?" Oh, it says there's a thunderstorm right over there. Oh, look, there it is.
Well, that's the kind of thing you want to know, then, right? But it's when there is an actual problem, it's really useful to be able to tell what the problem is, and because and also like what can you do to actually fix it. So that's what we're looking into, because it's it's about making the troubleshooting user experience really good and being able to surface all of the work that ISPs and vendors are putting into making networks good and creating good solutions. So
cool.
Being able to put that sort of in front of the end user when they need it, I think is going to be really powerful. So
that's really awesome. And I imagine, the next step is that nobody even knew there was a problem. It just sort of resolved itself.
Yeah. I mean, when you want to do that, right? So,
right.
Yeah. Sometimes the users need to help us because it's, there can be things that software can't fix sometimes. So you want to have that channel as well.
Right. Cool. That's awesome. So was it Network Xray that's called?
Yep.
Neat.
Yeah, there's a web page
really cool.
as well, so you'll be able to find it if you Google Network Xray.
Oh, cool. Yeah. I'll throw that up in some of the notation.
Cool. Thanks. Yeah, this has been great. Thank you for having me, Jason. That's
no. This is really
always
great.
a pleasure to talk to you.
Out of the list of people that I wanted to get in the first few episodes, I was like, what we need to talk about?
Thanks.
I have a need.
Appreciate that.
The need for consistent latency.
I love that meme.
Yeah, no, but the other reason that I really love your perspective is sort of in the standards world, when I started getting involved in it, I was dealing mostly with veterans, right? And having the perspective of somebody who was coming into it brand new, right? Like now versus when I did it was, I've always sort of appreciated that.
Yeah, totally. It is still dominated by veterans, right? It's I still saw someone posting images from Network X in Amsterdam last fall, and they were like, "Are there any people under 40 in
I remember the
industry?"
I remember that. And it's like, we're here. I mean, I'm barely above 40, but
yeah, it's good. Yeah.
Well, see, we need more people who aren't afraid to dive in.
Yeah, even if it's not on purpose, right?
Right. Even if it is not on purpose. Exactly. Especially if it's not on purpose. Cool. All right. Thanks, Bjorn. I will see you soon, I'm sure, probably in a couple of months. And we'll hopefully do this again next time, and or sometime soon when when we have some more stuff to talk about. I'm sure some stuff will come up. We didn't get a chance to talk about QED yet, which I think is really cool.
Oh yeah, true.
Yeah, we could have an entire conversation about that.
Absolutely.
Cool. All right. Thanks again. And I will close things the way that I usually close things. Please subscribe to our podcast so that you get our updates. Subscribe to us on YouTube if you haven't already. And by all means, own the things that you find nerdy, the nerdy things that you love, and have fun doing them. All right.